So our presentation today is about combating the response times for emergency vehicles to receive on-demand medical aid.
Okay, so the components used a C945 transistor and a lot of male and female wires, and we used ultrasonic sensor for detecting the distance of the emergency vehicle from the traffic light. Okay, so when it reaches 15
and it increases the sound like as about 500 hertz.
Since I'm also talking from here, it's showing green.
Green.
But otherwise, it would be showing.
Yeah. So it can all help decrease mortality rates. That's basically the main objective. Provide advancements in medical care. So there's also potential for patient data being used, such as using temperature as well as like the heartbeats per minute. So that can help prioritize which vehicles need to reach the ambulance first.
The most prompting problem that we face when colonizing other planets is to protect against the radiation levels. This is our lab of future internship project, Space Radiation Protection.
So our objective for the prototype is that it should be able to protect whatever's inside the dome from radiation levels and heat.
Now let us take an overview on the steps to achieving the goal of creating a Martian habitat.
The materials we use in the experiment are industrial canvas, carbon fiber, Kevlar, UV ray simulator, Arduino, breadboard, LDR sensor, DHT sensor, and some wires.
Now this is the final model. We kept the model in the fridge to dry from white glue. We'll first look at how much the light intensity is before we put the material. So you can see that the light intensity is ranging from 867 to 900. Now we can see the difference after we put the material on the LDR sensor. You can see when we flash the UV light, it came from 16 to 21.
It's around 20.
The range stays below 25. And hence it can be used for colonizing other planets
and building habitats.
Thank you.
It is like having localized Alexa, but only for your office.
Our project is basically a workplace assistant, and we have named it WASPA.
WASPA aims to automate tasks, improve efficiency, increase productivity, and ensure security.
We built a prototype which is able to control lights, answer basic questions, and displays the temperature in the LED display.
Then it also has the capability to go out and search the web if it needs to get up-to-date information, if the user consents to do so. It can answer questions like, what's the weather like, or tell me the latest news. It performed relatively well in terms of accuracy, 85.71%.
Turn off the lights.
Turning off the lights. 2 + 2 = 4. Temperature set to 25 degrees.
Summarizing WASPA, our goal was to make people who work in the office their life a bit more easier.
Hi, my name is Rohan. We are making a robotic arm that helps against hazardous materials. We have made significant progress and we've used Arduino as our main component.
So actually, since we've come here, we've learned a lot. For example, I've learned how to 3D model and 3D print, as well as connect Arduino circuits. We learned like the nitty-gritty, such as soldering wires together and like making motors work with like the code itself. And we have also learned how to use different like input methods, such as using potentiometers and joysticks to control like the arm and the motors in the arm.
And the real-world application of the arm we're building is to help handle hazardous material in certain workplaces, places where people don't get much money for the amount of work they do. So this is basically serves as a more advanced pick-and-place machine, which helps remove the human labor out of the equation in handling hazardous chemicals, radioactive materials, anything like that.
Hi, I'm Ishita.
Hi, I'm Nishka.
So our project is based on solving the problem that we mostly face when colonizing other planets, protection against space radiation.
So this is our Martian habitat that we printed using a 3D printer. We have used materials like carbon fiber and Kevlar inside.
So since our project is most based on experimenting, this is the Arduino and the breadboard, and this is the DHT sensor, and this is the LDR sensor, so we can measure the temperature and the UV intensity to know whether the material is adequate enough against protecting space radiation.
And to stick our carbon Kevlar hybrid to the Martian dome, we have used glue. So to dry the glue, we needed to keep the model in the fridge.
And unfortunately, one of our staff opened the fridge and thought this is something to eat, but glad they didn't eat it up because this was
Thank
really
God.
hard to make, so yeah.
I am so happy to have 3 young scientists in my chemistry lab in the Amity School, Dubai, who are doing some fabulous experiments with microgravity.
After completing the neutralization reaction under the microgravity conditions, we did it in the normal conditions and we found a purplish pinkish shade, whereas it was completely colorless in the microgravity.
We've been experimenting on microgravity conditions and how flames work under microgravity conditions compared to normal Earth conditions.